All right, welcome to our open house on restrictions on fish and wildlife consumption. I'm Madison Dugdale, the Remedial Action Planning Coordinator for the Detroit River Canadian Cleanup. With me tonight is Gina Panunzio, Community Outreach Coordinator for IRCA, as well as the DRCC Assistant. We also have Jenny Garib, the Special Projects Technical Assistant at IRCA, and Dr. Ken Droulard with GLEAR, and Kevin Money, the Director of Conservation Services at IRCA. So thank you all for coming. So our agenda for the evening is as follows. Going to start with a brief introduction about who the DRCC is, introduce BUI 1, and then I will pass it off to Ken, who's going to speak about his fish assessment research for about an hour. And at the end, we'll bring forth our recommendation to redesignate this. And finally, we'll end with a Q&A period. I know there's a storm that's going to be happening soon, so if there's any power outages, we'll make sure the online people get back in. So just bear with us if that happens. And to begin, I want to acknowledge that the land that we're on today is the traditional territory of Caldwell First Nation, who are honored members of the Three Fires Confederacy. So that includes the Ojibwe, Odawa, and the Potawatomi people. I want to recognize their significant contributions to the land and for taking care of the land and aquatic environment for time immemorial. And if you don't know about the land that you're on, you can go to native-land.ca, type in an address or your location, and it'll tell you about the territories, languages, and other information. So I highly recommend that you check that out. So this picture here is showing Pesh Island, and it has a quote from the early 1700s describing the Detroit River as an earthly paradise. And from this picture, I would totally agree with that. It looks extremely tranquil. But the river has faced issues throughout the years, which has led to its degradation. So some of these issues include the construction of shipping channels. So here on the left-hand side, you'll see Livingston Channel. They dug up the bottom, took out the big rocks, and this limited habitat for fish such as lake sturgeon. There was also the input of steel walls along the Detroit River, which limited habitat even further. And from industry, it inputted contaminated sediments such as PCBs and mercury into the environment, which can get into fish. This led to the Great Lakes Water Quality Agreement. And in 1987, this listed 43 areas of concern. And what an area of concern is where the environment is degraded compared to other areas in the basin. And this is when the Detroit River was listed as one of these 43 areas of concern. So each area of concern has what we call a remedial action plan, which is to help remedy the issues and hopefully remove them so that they're no longer an area of concern. So to the left here on this map, you'll see the Detroit River Area of Concern, or the AOC as we call it, in red, and that's what it encompasses. The remedial action plan, which is what the DRCC implements, has 3 stages or 3 steps. The first is to identify what the issues are with the river. Second, how can we remedy those issues? What are the actions that we can take? And third is the ultimate goal, which is to delist the whole river. And our goal is just to kind of analogy to take it out of the emergency room and put it back into the waiting room. So who is the DRCC? Well, it isn't just a few people, it's multiple people together working hard to get the river in a better state. So we are guided by the Steering and Implementation Committee, who guides our actions and what our priorities should be, as well as the Public Advisory Council. So that includes municipalities, governments, NGOs, environmental organizations, as well as members of the community like yourselves who are interested in the restoration of the Detroit River ecosystem. So the Great Lakes Water Quality Agreement gave us 14 beneficial use impairments, also known as BUIs. And what a BUI is something that just interferes with our enjoyment of the water. So that could be economic, recreational, or ecological. And each one of these BUIs has criteria we have to meet and check off so that the area of the Detroit River can no longer be an area of concern. So it can range from beach closures to impacted sediments, as well as the restrictions on fish and wildlife consumption, which we're focusing on today. So in 2010, this is what our BUIs look like. So on the left here, you can see a majority were red or impaired and required further assessment. And we only had 3 that were not impaired. So there was a lot of work to be done. And from about 2000 to 2020, we had 277 habitat projects that were completed, such as tree plantings, but I really want to focus on the contaminant reduction work that has happened by the DRCC and partners and the community. So the first being the retention treatment basin in Windsor. So what this basin does is it collects stormwater and treats it before it's being discharged into the river, instead of it collecting all the contaminants going directly into the river. Also, there was sediment that was removed from the Grand Marison drain, and this was contaminated with PCBs, so that was removed, which improved the environment there. And there was the addition of stormwater retention ponds, which kind of act just like the retention treatment basin. It collects the stormwater, so it's not going directly into the river. There's also been upgrades to the Amherstburg wastewater treatment plant and the Lou Romano reclamation water facility. So 2010, that's where we're at now. As of today, you can see the massive difference that has been made. We only have 3 left that are impaired: the loss of fish and wildlife habitat, the degradation of fish and wildlife populations. And today, what we'll be focusing on is the restrictions on fish and wildlife consumption. So for this BUI, it was impaired in both the stage 1 and stage 2 remedial action plan report. And Ken's going to really go into detail more about that. And as I mentioned previously, each BUI has criteria, or there's check marks that we need to do to improve them so that they're not impaired to make sure they're not impaired. So for this BUI, it will become not impaired when consumption advisories for indicator fish species, so such as walleye, brown bullhead, smallmouth, largemouth bass, given for the sensitive population, so that's children under 15 and people who can become pregnant, in the area of concern are similar to upstream and downstream non-area of concern Great Lakes reference areas due to contaminants from locally controllable sources. So in order to assess this BUI, one part that we did, one of our working groups suggested that we do an angler survey. So in 2019 to 2020, we spoke to anglers on the Detroit River, and we asked them various questions. And I just wanted to highlight some key results from this survey. First being that over 90% of our respondents ate 8 or less meals of Detroit River caught fish per month. And this is important because 8 meals is what we call the benchmark. And this is due to bioaccumulation or the gradual increase in contaminants in a fish over time, depending on what they eat or the environment. We also looked at how often the indicator species are consumed. And the key one that I want to point out here is that walleye were consumed by 89% of our respondents. So it's a really popular fish. And if you're a fisher person, like I'm sure that you've all seen walleye or went pickerel fishing. They're always really exciting to catch and eat. So tonight we have various resources here in person and online, which we'll share in the chat for you to check out for yourself. We have a fact sheet that describes the research that was done and summarizes it. We have a comment form. So if you agree or disagree with this redesignation recommendation, you can write it there. Or if any questions that we don't get to today, you can also input that. As well, that we have an Eat Safe Fish brochure. So if you're fishing, you can take this brochure. We also have the online version as well through the link. And it tells you how many safe meals you can have of a certain fish species, depending on its size. So it's a really great, handy tool to have. With that being said, I will let Ken speak about his research. Thanks.
All right, thanks, Madison, and hello, everybody. My name is Ken Drouillard. I'm a professor at the University of Windsor, and I've been affiliated with the Detroit River Canadian Cleanup Committee since 2005. So I'm part of their steering committee and their research and monitoring group as well. I also am the director of the School of the Environment at the University of Windsor. So we have a couple of undergraduate programs. One is a Bachelor of Environmental Studies, and the other is a Bachelor of Environmental Science. And I see an awesome T-shirt there with a GLEAR of the Great Lakes Institute for Environmental Research, and also have been affiliated with. So we're going to see a little bit of redundancy in some of our slides, but that's good. Redundancy just means things are probably correct if we agree on 2 separate speakers. But for a little bit of a history lesson here, the Great Lakes Water Quality Agreement is an agreement, but it gets its authority by its nesting within an international treaty signed between the US and Canada. This treaty is called the Boundary Waters Treaty, and it was signed in 1909. Basically, the way in which the Great Lakes Water Quality Agreement was situated is because we had this existing treaty And that Boundary Waters Treaty was really about water quantity and water security. So it was really about concerns largely driven by the opening of the Chicago Canal, which was a major diversion out of the Great Lakes. And those concerns generated a lot of legal issues between the different Great Lakes states. The upper Great Lakes states were worried that the state of Illinois was basically depleting water supplies from the upper Great Lakes. So that was the motive for the Boundary Waters Treaty. And the conflict was resolved through the US Supreme Court actions. And they had so much conflicts that they started to think about, well, what happens if there's conflicts between US and Canada over water quantity? So that's what motivated. And you might have even heard last year there was some, so you might even heard last year there were some rumblings by a certain person on the US side talking about wanting to get Canadian water. Well, that would come under the auspice of the Boundary Waters Treaty, should those requests happen. And in fact, IJC has very special quasi-judicial powers in mediating those conflicts between US and water states. But the people who wrote that treaty in 1984 had some, or in 1904, had some insights that essentially they added this one little clause, said neither party will pollute the waters of the other. Okay. And what they were thinking about at that time, they were thinking about cholera. They were thinking about human pathogens. And again, motivated by the Chicago Canal, because the whole reason the Chicago Canal was built was to divert sewage from the city of Chicago away from the Great Lakes, from Lake Michigan, where their drinking water intake was. And that left basically downstream cities in St. Louis a little bit peaked, right? You're sending us all of your sewage. So basically, it wasn't until 1972, and this is basically, we had this growth in this era of an environmental movement. Basically, just 2 years earlier was when the US EPA was actually formed as an organization. Environment Canada became formed as an organization in 1970. We had our first Earth Day in 1970. So all of this growth in environmental consciousness helped facilitate this first agreement signed again between the US and Canada and situated under that Boundary Waters Treaty. And basically it gets renewed, so it's considered a living document. So it's basically been renewed 4 different times. 1972 was the start, 1978, 1987, and then the most recent rendition of the agreement, 2012. That newest agreement adds things such as climate change that was a non-issue at the time that this agreement was formed. Early in that agreement, almost all of the focus of the Great Lakes Water Quality Agreement was on harmful algal blooms and eutrophication, an issue that we still see a little bit today. But by the time 1978 rolled around, there's a lot more public consciousness about toxic contaminants in the environment. This was motivated things like by the Love Canal. Anybody here heard of the Love Canal? Okay, so a huge issue where basically a hazardous waste disposal site was used, accumulated waste for many, many decades by the Hooker Chemical Company. They put the dirt path over it, made it into a nice lawn, and then sold it to a school. And the neighborhood grew up around there. Eventually, the hazardous waste leached out, and it basically caused reproductive impairments of people and families living around that area. So that was a huge issue. We also had issues like the Akwesasne people on the St. Lawrence River being exposed to high degree of contamination. We had the closure of Lake St. Clair's commercial fisheries due to mercury. So all of these things kind of brought toxics into the focus. And by the time 1987 rolled around, that's when we had the basically Annex 1, which represents these areas of concern being built into the water quality agreement that Madison was talking about. So Madison's already sort of talked about this. The whole point of establishing these initially 43 areas of concerns is that these were the most polluted parts of the Great Lakes, and that we have to basically clean up the dirtiest parts first before we can work on restoring the lakes as a whole. So that was the idea behind this. And what was unique about this is the whole philosophy of taking it from a ground up approach or a bottom up approach to cleanup as opposed to a top down. So every area of concern established its own remedial action plan, its own RAP. And that RAP committee composed of local stakeholders, as Madison had indicated, as well as some of the government agencies involved as part of that cleanup. And then basically each RAP goes through these 3 stages. The first one, really identifying what the problems are and doing assessments for each of those beneficial use determinants. Stage 2 is really the meat of the whole RAP process. This is where you formulate your plan for how to basically fix the problems in the system. And then basically you keep doing restoration activities, and then you keep retesting to see if all of your beneficial uses have reverted back to an unimpaired status. Once you get everything through and back to unimpaired, then you can move to stage 3, back to the listing stage. So we've been in this, by next year, we'll be 40 years in the process of Great Lakes areas of concern, 4 decades. So of those 43 areas of concern, we do have some progress. So in Canada, there's 12 original areas of concern wholly within the Canadian boundaries. 3 are now delisted. The closest one to us is Wheatley Harbour. That used to be an area of concern, now it's delisted. There's also 2 that are basically considered in a stage where all of the actions have been completed. The system is going through what we refer to as natural recovery, and we're sort of waiting for those last beneficial uses to revert back to an unimpaired status. But we still have 7 still in this process of stage 2. On the US, 26 areas of concern originally, 4 delisted, 10 where all restoration actions are considered completed, and still 12 in stage 2. And then we have 5 unique international AOCs where part of the boundary fits in Canada and the US. And these are all of the connecting channels. These are St. Mary's River, St. Clair, Detroit River, Niagara River, and the St. Lawrence River. And they're all in stage 2. Okay, basically, Madison's already showed this slide. These are the 14 beneficial uses that every one of those areas of concern are evaluated against. So it's a fairly standard approach. And really, when the 1978 version of that Great Lakes Water Quality Agreement came out, they invented a new language, or at least a new set of words called ecosystem management. Okay, what does that mean? Nobody heard of ecosystem management. It's actually a Canadian invention by the Canadian commissioners of the agreement at the time. And ecosystem management means, okay, instead of just looking at chemical parameters and saying, okay, we've achieved chemical parameters, and therefore the system must be good, what we're going to do is we're going to look to the environment. We're going to look to nature and ask the system, is the nature healthy? So part of that, what's embodied in these beneficial uses are different classes of organisms representing all different trophic levels, from phytoplankton to zooplankton, to invertebrates, to fish, to wildlife. So basically establishing their health. And then there's also these things that are beneficial uses to us. What does the system give us, to society? Okay, and again, those are things like fish to eat. Those are things like recreational attributes. So all of these beneficial uses are trying to establish that perspective. As Madison indicates, the Detroit River Canadian Cleanup Committee, and there's a sister US implementation committee on the US side that do talk together and coordinate on a regular basis. But we're consisted of multiple local stakeholders that are trying to clean up this system together. And basically, the process that this RAP has went through, our stage 1 was actually completed in 1991. It wasn't until 2010 that Canada came up with its formalized stage 2 delisting plan. And then you can basically look at the 2025 updated plan that's on the DRCT website. The website is down there. Highly encourage you to take a look at that website. There's lots of great information and publications there available. So, Madison's already talked about our current status. So basically, 3 of those beneficial uses are still in the impaired status, but everybody else has been reverted to unimpaired. And again, this is like a huge success story. This is, in 15 years, we went from, the scales towards things progressively to the worst, towards things tipping to much better. And this is lightning speed when it comes to environmental recovery. All right. Now I guess I'm going to start talking about the topic, right? Okay, so we're here talking about the fish consumption restrictions. And as I say, all of the areas of concern use fish consumption restrictions and sometimes of wildlife consumption restrictions. Although in Ontario, we have no active wildlife consumption restrictions in place right now, but we have a lot of fish consumption restrictions. We'll go through that. And we use not only the presence of fish consumption restrictions, in other words, advising that you should only eat so many meals per month of fish of a given species from a water body, but also the intensity. So, an advice that you can have up to 16 meals per month is not really all that restrictive compared to something that says do not eat, right? Do not eat being the most restrictive of all. And in fact, it turns out that in Ontario's Guide to Eating Fish, which covers more than 2,700 lakes across the province, there is no such thing as a water body in Ontario that has no fish consumption restrictions. It just turns out if you're a fish and you're big enough and you're old enough, you'll eventually accumulate enough mercury to trigger some kind of advisory. But they vary from one system to the next. Is everybody in this room, are you familiar with the Guide to Eating Ontario Fish? Show of hands. Okay. Yeah. So they used to have an ingenious mechanism of making this available. They used to put the guide, physical printouts of the guide, where you bought your angling license for fishing license. And then they knew where most of the fishermen would end up eventually. So they'd also make them freely distributed at the beer store. So, it was a great way of doing things. Unfortunately, the guide is mostly online now, but it is amazing. The website is super technical. It's really easy to use in the sense that, you can basically search out your water body by name. You could scroll through the interactive map and then basically, click on each item and see which advisories are in place. Okay, so basically, the way this program operates is they typically return to each water body about every 4 to 7 years. They return to areas of concern more frequently because of their contamination status. MNR basically collects the fish, and then they send them off to MECP for contaminant analysis. And then they basically keep a contaminant analysis database, and then working with Health Canada on the benchmarks for allowable intake for different contaminant classes, they set up these meal advices. And most of these water bodies have been assessed for a whole series of different contaminants. And I have those highlighted in red are the ones that generate fish consumption device in the Detroit River. Those include mercury, PCBs, dioxins and dioxin-like compounds, and these PFAS substances, the forever compounds that we've been hearing about more and more lately. Okay, so if you wish to go to the guide, you can easily just type in Guide to Eating Ontario Fish in the website. It'll take you to the online interactive map. If you click on the little fish icons in the Detroit River, there's actually 2 zones. There's an upper Detroit River zone and a lower Detroit River zone, and separate fish advice given. If you click on the consumption tables, you'll get something like this. This is established for yellow perch. And it gives you basically at the top, you've got the species name, and then you have the size, and then you have a set of numbers that tell you how many meals you could safely eat per month without exceeding the thresholds of any of those contaminants of analysis. So in this case, for yellow perch, between 25 and 35 centimeters, you could have 12 meals per month. That's a lot of perch. Each meal is 8 ounces, so there's a little, about the size of your palm of a fish meal. Okay, sensitive population is going to be a little bit more restrictive than the general population. That consists of women of childbearing age and children under the age of 15. Again, just a couple, and you'll notice that for some species, the advisories are much more intensive. Common carp, only advised to eat no more than 2 meals per month for the general population, and women and children shouldn't be eating common carp. from the Detroit River. Okay. So Madison read off the listing criteria. I've truncated it. The original stage 2 wrap had just walleye, brown bullhead, and smallmouth bass. We added in largemouth bass in the interim stages because there was no data on smallmouth bass. And then NECP, hearing our concerns that they're missing data for this fish species, they went out and collected a whole bunch, got some data, and put some advisories in place. So we're actually able to work through the framework as it was originally stated. Those 3 species were chosen with a specific purpose. So brown bullheads are more of a local fish species. They're a bottom feeder, and because of their interaction with sediments, they tend to accumulate sediment-associated contaminants. Smallmouth bass and walleye are both upper trophic level predators, so they're piscivores. They tend to eat more fish. Smallmouth bass and walleye include a mix of invertebrates and fish, but when they get big enough, they're pretty much all eating fish. The smallmouth bass tend to be more local, and the walleye tend to be more regional. So we can get basically those different profiles across those species. And in Canada, we've adopted this sort of standardized framework for how we go through a fish consumption assessment. And it basically goes through these different tiers. And what that does is it allows us to ask specific questions in each of those tiers that represents different aspects of that delisting statement. So under tier 1, it's the most simplest of all. We just look at the intensity of the fish advisory. We say, are the fish advisories in place considered restrictive compared to what people actually eat from the system? So, so you might have, the maximum advice is 32 meals per month. How many people eat 32 meals per month? That's fish every day, wild caught fish every day, plus an extra fish, in two meals in one day. Okay, tier 2 is essentially asking, are the fish advisories in your AOC more restrictive compared to other non-AOC zones or compared to your reference? So that's the bar you're sort of saying. You're saying, well, you may have advisories, they may be more restricted than we like to eat, but are they more restrictive than everywhere else? So that's the bar that we're looking at tier 2. Tier 3 is where we actually move away from looking at fish advisories per se, and we start looking at the actual chemistry, the contaminants present in fish. And we've got multiple evidence lines that sort of ask ourselves, spatially, is the fish contamination more intensive than reference? Temporally, is there evidence that contaminants are actually declining with time? And how long will it take us to get to the unrestricted benchmark? And do we have evidence that those fish are actually picking up their contaminants from within the AOC? Because fish are like us, they move around, they swim around. They don't always constrain themselves to our borders. And in the Detroit River, that's complicated because we got an international boundary line, with 2 different jurisdictions. And the fish don't actually have to go through a customs agent to cross that boundary line. They just swim around and integrate components. Now you'd say, well, the river is a river, right? So fish should be moving around and everything else. But there's actually quite a distinct difference in the contamination on the US side compared to the Canadian side. And that's basically because of hydraulic focusing, that the water is flowing so fast through the Detroit River that when you have point sources coming through coming into the shoreline, that flow of water tends to smear it downstream as opposed to mixing across the river. So that allows this sort of situation to set up where you have more contaminated side of the US compared to the Canadian side. Okay, tier 4 is sort of our, if nothing is matching tier 3, tier 4 at least allows us to look at all the other evidence lines. Is the environment improving? Is our contaminants decreasing in water, in sediments? Are there further restoration actions that are happening? And is that going to affect fish contamination? So tier 4 is that last stage. And once we get through all of these things, we can ask ourselves, are we impaired or not impaired? Okay, so Madison's went through the fish survey that IRCA and DRCC basically put out. And part of that information about the fish survey was to tell us what would be an unrestricted benchmark for a number of fish meals. And in that case, that key statistics, more than 90% of anglers who catch and consume fish from the Detroit River do not consume more than 8 meals per month. That's 96 wild caught fish meals a year. Okay. And that matches broader angler surveys across Ontario, where it's very infrequent where people eat more than 8 meals of wild harvested fish in a year. Some people do, but that is sort of the regular. So we adopted that as our sort of unlimited consumption benchmark. If you're on 8 meals per month or more, so 8, 16, 32 meals per month, none of those are considered restrictive per se because most people aren't eating that many fish. Okay. All right, so when we go through tier 1, we've got our 3 indicator species. We can basically list all of the advisories that are in place for those 3 indicator species. And these are basically the number of meals allowable. Again, our target is 8 meals per month. So anything at 8 meals per month is highlighted as in green. And those in red are less than 8 meals per month. And you'll see that for each 3 of these species, there's basically some impairments with respect to tier 1. In other words, more restrictive advice compared to the unrestricted benchmark. So that basically means, we go through tier 1 and we've got a failure and we got a failure for each of our 3 indicator species. So because they all failed tier 1, we're going to move into the tier 2 framework. And in the tier 2 framework, we're asking that question: is the degree of intensity of a fish advice in the AOC more restrictive than reference? And here what we use is all the Great Lakes fishing zones that are not AOCs. So basically, and then we compile all of the advisories in place for the same size bins of that species in those reference zones. We compute the median value and we compare that median value to our fish advice. In this particular case for brown bullhead, we have one of our meal advice that is more restrictive than the reference. Again, we fail for that criteria for the species. And again, we end up with a couple of passes for some of the populations for our 3 indicators, but by and large, tier 2 tends to fail. So it's looking scary here, right? We went through tier 1, everyone failed. We went through tier 2, everything failed. So now let's dive deeper into the chemistry of the fish and see what's going on. And that's what our tier 3 is. And we have 4 different evidence lines that we're going to look at. Each of these evidence lines are going to be basically then kind of counted. We're going to say whatever majority of evidence lines wins. It's like tossing a coin and seeing how many extra heads or tails. Hopefully in this case, because we got 4 lines, we don't get a tie. All right. So the very first one is what we refer to as virtual advice. It is very much almost the same as tier 2. The only thing that's different is that we are actually taking the fish chemistry and we are computing advisories in the exact same way that MECP does. But the difference is that we're going to truncate the fish records to only fish records taken from the last 10 years. And one of the issues with the official Guide to Eating Ontario Fish is some of the records that are included in new sets of advice could be as many as 25, 30 years old. Okay, so they don't necessarily reflect the state of the system as it is today. So we restrict those records to just records in the last 10 years. We're also able to add in other data sets. So beyond what MECP uses, GLEAR at the University of Windsor, we have our own analytical labs. We've got a lot of fish contaminant records, and we can add to that data set and embellish it and use a broader array of records. And then finally, we're only going to consider the priority pollutants for the rat, which is mercury and PCBs. Okay, so now we run through our virtual set of advice. And for the brown bullhead, now we failed tier 2 for the brown bullhead, but when we run our virtual advice and we just restrict ourselves to the newer records, plus a much larger database of records that were generated, some of these from MNR, some of it from GLEAR. It was related to an independent fish tumor survey. We actually find the virtual advice passes both tier 1 and tier 2 for brown bullheads. So we think that basically the latest guide to eating fish might be a little bit overly restricted. Same thing for walleye. So walleye has a set of fish consumption restrictions based on the virtual advisories, but they're pretty much identical in intensity compared to the reference. So if we're comparing the second last column to the very last column, which is the reference, we find that either the advice is similar or the advice is at least more than 8 meals per month, which is considered unrestricted anyways. Okay, so walleye passes tier 3. Then we look at smallmouth bass. Smallmouth bass fails. Okay, and the reason smallmouth bass fails is primarily for mercury for the sensitive population, but it also fails for PCBs. And this one is like one of those agonizing things about statistics. So when you compute the geometric mean of PCB concentrations in smallmouth bass, it works out to 106 nanograms per gram, and the actual benchmark value is 105. So it's like one part per billion higher than the trigger for getting us to an 8 meal per mark. So that one is kind of like a bit of a tentative one, but mercury, it is a resounding failure. Okay, so basically under tier 3A, passes for brown bullhead and walleye does fail for smallmouth bass. Okay, next we actually look at the contamination in the fish, and we're going to do statistical assessments. We're going to say, is there a statistically significant difference between mercury and PCB concentrations in fish from the AOC versus reference? So I'm not sure how well these things are clear, but the red dots represent the reference and the black dots represent the area of concern. We have mercury on the left side and PCB concentrations on the right side. And the bottom axis is the size of the fish. Excuse me. So we see for mercury, the mercury concentrations increase as a function of size. So the larger the fish, the higher the mercury concentration is. And when you adjust for that size, statistically, the slope is the same. But what you tend to find is there's larger brown bullheads collected from the Detroit River compared to most of the reference size. That's why the red dots are to the left of the graph for the most part. But statistically, there's no significant differences. And the same with PCB, statistically, there's no significant difference. The brown bullhead passes tier 2. Same with smallmouth bass here. Here we've got the red dots are the reference, and then the big black squares represent the smallmouth bass from the Detroit River. And you can see that those the squares are falling within the cloud of points that the red dots are. No statistical difference, either for mercury on the left side or for PCBs on the right side. And for walleye, same scenario. Again, we're at the sort of the top part of the red clouds for mercury, but we're still not statistically different, and neither is the case for PCB. So in this case, tier 3B passes. So the actual chemistry of the fish is the same in terms of reference versus the Detroit River for the three indicator species and the 2 priority contaminants. Okay, next we look for temporal recovery. There wasn't enough data on brown bullhead to really get a satisfactory temporal trends. There's very limited, and I would say insufficient data for smallmouth bass. But in this case, we do see a declining trend in mercury between 2008 and 2023. PCBs, there is no trend. For walleye, there's basically no statistical change in mercury concentration decline in walleye from the Detroit River over time, but PCBs are actually declining. So that's showing statistically significant improvement. So this is our sort of our tier 3 summary, insufficient for bullheads. We got a no trend for smallmouth bass for PCBs, but supportive for mercury. For walleye, no trend for mercury, but supportive for PCBs. Okay, the last part and the trickiest one to answer is, are the fish actually collecting and obtaining their contaminants from Canadian waters of the Detroit River? And I stress Canadian waters for the Detroit River because that's the question we're trying to answer. Okay, and here what we were able to do is take advantage of unique chemical signatures. So all of these fish are basically remembering their chemical exposures from their travels all around. And that generates essentially like a fingerprint of where that fish is traveling. These contaminants are basically essentially not eliminated from the fish tissues over that fish's lifetime. So essentially that fish is remembering every meal that it's consumed, and that's contributing to the chemical signature in its body. And what we did is we sort of evaluated where different, so these are basically pictures of where fish were caught in different areas. So the Lake St. Clair fish are in pink, the Western Lake Erie fish are in green, probably because it has the elephants, right? And then we have basically the US side of the Detroit River in blue, and then the Canadian side in red. And I want you to take a look at the left graphic, which is the smallmouth bass. And you'll notice that those polygons, those shaded areas are distinctly separated, right? They're distinctly separated. That's basically saying fish caught in these different regions have unique chemical signatures. But sometimes some fish don't fall into that category. So some of the fish caught in Canadian waters of the Detroit River actually look a little bit more like they fall into the blue sections. And if you stare really closely, we've got little dots, tiny dots in those circles that represent the different identities. When we basically put all this up, smallmouth bass, as we suspected, is a lower, more localized fish. It spends more of its time in the place of where you caught it. And it turns out that if you caught a smallmouth bass from the Canadian side of the Detroit River, there's a 50% chance that fish has spent its entire life on the Canadian side of the Detroit River. Okay, there's about a 20% chance that it'll cross into the US water, and there's about 30% chance. Now, walleye, these people like to pack a suitcase. They like to move around. And if you catch a walleye from Canadian waters to Detroit River, there's only a 1 in 5 chance that walleye has actually spent its life in Detroit River. They like to travel around. About 32% of them are likely to cross over into the US side, and almost 50% of them are moving either in Lake St. Clair or Western Lake Erie. In fact, most of those walleye are Western Lake Erie fish. Okay, now that we can actually identify the Canadian and the Canadian smallmouth bass and the Canadian resident walleye, we can basically say, let's just look at the Canadian residents and see if retest the criteria on that. And when we do it, we get a little bit mixed results. So for smallmouth bass, they pass the virtual advisories, but they're slightly higher contaminant concentrations than reference. For PCBs, though, they distinctly pass. And then for walleye, virtual advisories, they seem to fail for 1 or 2 size classes, but they pass the statistical test. So now we put together all these 4 evidence lines together, and we do our weighted evidence assessment. So we're counting how many passes in tier 3, A, B, C, and D, and how many fails. And we're basically going to come up with a recommendation. So for brown bullhead, we only have a limited number of evidence lines, tier 3A and 3B, but they both pass. For smallmouth bass, we get a majority of evidence lines that fail, and they fail because of mercury. Okay. And for walleye, we get a majority of evidence lines that pass for both PCBs. So our biggest issue still is in tier 3, where we get 2 of them that finally get to a pass from bullhead and walleye. We can move those to the beneficial uses unimpaired for those 2 species. But we still got smallmouth bass failing, and it's failing because of mercury. So now we're in our last ditch effort. We're going to look at tier 4. And we're going to ask, what's the evidence that the environment is actually improving with respect to mercury over time? And is that likely to translate into a reduction in fish contamination? Okay. So we're basically going to look at multiple evidence lines again. What is mercury doing in water? What is it doing in suspended sediments? Can we track the source of mercury into sediments? Is it from Canadian shoreline of the Detroit River? Is it from US sources? Is it from upstream? What are the sediment differences, particularly between the US and Canada, but also with Lake St. Clair? And what is going on the US side? What are their planned restoration actions? And is that likely to help us out? So unfortunately, we don't have whole water mercury monitoring data for the Detroit River. We have excellent water monitoring data for PCVs. I'm not going to show that today, but PCVs are dropping with a half-life of 8 years in the water column. But we do have some good data set for the St. Clair River. This is at the lower downstream section. So basically those red dots represent 20 years of monitoring whole water mercury levels. And that whole water mercury has been dropping at about 8% per year. Okay. There was a lot of studies looking at mercury isotopes. So isotopes, these are stable isotopes of mercury. So isotopes are basically the same element with different numbers of neutrons. Okay, in that element. Okay, so basically, and for mercury, it turns out that the types of mercury isotopes are present is diagnostic of the type of source. And one of the biggest source to the Huron-Erie corridor for mercury was former chlor-alkali plants that are operating in St. Clair River, part of Dow Chemical, part of Chemical Alley. And that has a very, very distinct and unique isotopic signature of mercury. And it's different from other mercury sources like coal combustion or gasification. Okay, so when we looked at the sediment of the downstream sections of the Canadian side of the Detroit River, we found that it had an isotope signature identical to Lake St. Clair and St. Clair River. When we looked on the US side of the downstream sediments, it had a wholly different isotopic signature. Okay, so what is that telling us? It's telling us that most of the mercury coming into the Canadian side of the Detroit River is derived from upstream sources, coming from that old chlor-alkali plant that was shut down in 1977. And those sediment particles are working their way through the Huron-Erie corridor over time. It's going to take centuries for that reservoir to move out into Lake Erie. But it also tells us the US side has its own sources of mercury, and they have their own unique sources. Okay. So collectively, mercury and sediments are sourced from outside the AOC, not from within our watershed. Now we looked at mobile particles. So they use basically these sediment traps. So it looks like a big cone, and you mount it at the bottom. And when particles hit the top of that cone, the water flow slows and they settle to the bottom. So what these sediment traps, they basically collect those particles that are moving down through the system, coming from upstream. Every time you have a storm event and you resuspend a bunch of sediments, the water flow pushes them downstream a little bit. So that represents this flow of contaminated particles through the Huron-Erie corridor. And we see that over time, over 20 years, basically the mercury concentrations in those mobile particles are dropping. And what's really important is the rate at which they're dropping is identical in the Detroit River as it is for Lake St. Clair. So it's basically telling us that the cleaning up of Lake St. Clair is contributing to the cleaning up of the Detroit River. That's what dictates that rate, because that's the source of our contaminated particles. Okay, I just had a PhD student who just defended in January. Her whole thesis was on basically using machine learning and artificial intelligence approaches to spatial interpolation. So she came up with a whole protocol for basically training AI models to, instead of telling you, what your horoscope is for the day, they're training the AI models to basically interpolate sediment contamination in a smart way, in a way that accounts for things like flow conditions and depth and positions relative to historical sources. So they're much more advanced than off-the-shelf geographic information systems. And when we generated these maps of contamination, so we have mercury on the left side, we have PCBs on the right side. Green is good, okay, red is bad. So I'll direct your attention to the PCBs right now. That's looking pretty damn good. And most of those PCBs are pretty much restricted to the downstream Trenton Channel area. Okay, mercury, we see a lot of hot spots lighting up in Trenton Channel and downstream of it. But a lot of light green, so a little bit higher mercury than compared to PCBs relative to sediment quality guidelines. It's still pretty distinct differences in a gradient. And I said, US side of the river is a little bit more contaminated than the Canadian side. Okay, good news that EPA and Michigan Eagle are stepping up to the plate with a monumentous sediment restoration initiative. They got over 5 square kilometers, and it basically covers almost the entire shoreline, longitudinal near shoreline of US side of the Detroit River. And those are basically being designated and targeted for sediment remediation. So they're going to do some capping of those sediments and to geochemically lock those sediments away from biota. So that's going to basically have an important impact. So when we coupled our GIS maps, this is a sort of a before versus after scenario. So which sediments are going to exceed 3 times the sediment quality guideline. And you see that basically the amount of red on the US side of the Detroit River today compared to the left, this is essentially what we expect after cleanup has happened. We're going to see a major cleanup in the curve. I also did a lot of modeling work, but it was mainly for PCBs, and we're talking more about mercury. But the modeling work basically says Canadian caught fish, particularly, remember I talked about smallmouth bass and walleye spending a certain portion of time, about 20 to 30% of their time on the US side. They're going to benefit from the cleaning up of the US side of the Detroit River. That means our fish are going to actually drop their fish. Okay, so we've got all of our evidence lines for the environment that mercury is basically cleaning up in the Detroit River, and we expect that to translate into reductions in mercury in our fish. And indeed, we're seeing the reductions in mercury, at least for the smallmouth bass. So basically, we end up at this very aspect. So the tier 4 evidence lines are distinctly passed, particularly for mercury. And even though smallmouth bass failed tier 3 for mercury, we feel that the multiplicity of environmental improvements are happening are going to basically lead to those mercury concentrations dropping in that fish in a fairly short order. So we're expecting these changes to happen within on the order of 10 years. Okay. So on that basis, we're making the recommendation that on the Canadian side of the Detroit River, that we recommend that the fish consumption restriction be considered unimpaired. So that's sort of the final conclusion based on what our delisting criteria is, our qualifications. So while mercury remains elevated in smallmouth bass, the majority of evidence lines show that mercury is improving in Canadian water system, with further improvement with US restoration actions. And these improvements are expected to translate into reduced fish contamination and intensity of fish consumption in bass. This one's Madison's.
Yeah. The presentation, Ken. I just wanted to talk about the redesignation timeline before we go into our Q&A. So what the next steps are, right now we're engaging Indigenous communities and the public until April 30th, providing feedback, comments, and answering questions about this BUI. After that, it's going to go to the 4-agency management committee. So that includes 2 Canadian and 2 American governmental agencies who help oversee some binational AOCs. So that'll be with them for 2 months. And then after that, it'll go to the Canada-Ontario Agreement Annex leads for another 2 to 3 months. So as you can see, it really will go through a rigorous process before it can actually be redesignated to not impaired anymore. So now we're going to go into our Q&A period. So we have, you can scan this as an online form as well, and then we have the in-person copies. We'll also provide the comment form link in the chat. So if you don't have any, if you have questions, but you don't want to ask them today, you can write it down or go online and we will get back to you. But if you want to ask them today, we'd love to hear it. So if there's any questions online or now, just let us know. Oh, okay. All right, we'll share. Hey, Giovanni, we'll wait for Ken to get a drink first. And then, yeah. Yes. All right, yes.
So you're asking to delist, but it's all proposed, it's kind of, you're delisting from something that hasn't happened. Isn't it a result of this proposed mediation along the, I don't know where it is, that the Michigan side, right? So that's proposed, but you want us to delist something that you're assuming, right, that it's gonna be improve the fish habitat, but that hasn't even been done with the government of the United States, and even our provincial government, for that matter, what they do with legislation on the environment, totally destroying any efforts that we're doing. We're kind of going back to the seventies and fifties and opposed to improving. So we're kind of, saying, yeah, it's gonna improve, but we don't really know. Shouldn't we wait until all those remediation efforts have been done?
I think it's a really great question. If all my evidence lines of environmental improvement were just hinged on waiting for the US to happen, then I would completely agree with you. But we do have good evidence that Lake St. Clair is actually cleaning up. And upstream of that, the St. Clair River. So MECP just completed the last of its sediment capping exercise in the St. Clair River, right around Stag Island. And that's to take care of any historical legacy mercury issues remaining. So basically, those particles that are filtering down are moving through the system. That's what our fish are, for the most part, being exposed to. So I think the US actions are going to help, but we are already on the path of things cleaning up with tangible empirical results that the environment is getting better with respect to mercury.
Is there a timeline for that exercise as far as the soil remediation?
So on US side,
Correct.
so the last US partner meeting I seen, they had a very ambitious timeline of 10 years. I think it's ambitious, but hey, dream big.
Are there any additional questions in person? Oh,
You talked about the US side with the, locking in of the sediment. How is that actually done?
Okay, so
In order for it not to move, that would be
Yeah.
interesting to see. How are they going to do that?
So the typical, there's different mechanisms, and actually all of the different mechanisms have been tried in the St. Clair River in the past. So there's hydraulic dredging and removal. That was done actually in Connors Creek in the past in the Detroit River. And the issue with hydraulic removal is, well, one, you're removing contaminated sediments, and then you got to put it somewhere, right? So that usually they put it in a confined disposal site. But those confined disposal sites, that's just another place. Like you're moving your problem somewhere else. So the other problem is they do try to put up booms to contain the solids, but when you're dredging this stuff up, you're mobilizing a lot of that particle. And even in the process of dredging it up, some of the contaminants associated with those particles is going to dissolve into the water, and you're going to potentially recontaminate the water. So pulling it up isn't always the best solution. So the capping exercises, what they end up doing is they lay down usually a geotextile cloth of carbon fiber over top of the contaminated sediments, and that carbon fiber acts like a sponge. Okay, it will lock it in place, but then to hold that geotextile down, they usually dump a whole bunch of crushed stone and cobbles on top of it. The good news is that carbon fiber basically prevents any underneath sediments. It effectively locks away the biogenic zone to be above the contaminated zone. So and the other thing is all that crushed stone is like awesome fish habitat. So it's a great place for fish eggs and other things. So,
Thank you.
yeah.
any questions online? In the chat?
Not yet.
All right.
What about that love canal that you spoke about?
So it's Niagara Falls on the US side.
Hearing no other questions, we highly recommend that you fill out our comment form if you agree, disagree, or unsure about the redesignation recommendation. And if there are no further questions, we just want to thank you for coming out tonight. Please grab a bite to eat for those in person, and check out our tables before you leave for the night, and safe travels. Thank you.
Thank you.
You got more questions?
Sorry.
Showing it on camera?
Want me to go up there?
No, no,
You want camera? Sure, that would be great.
Yeah, you can come up
I
here.
think we want to capture.
Yeah,
the
exactly.
question.
Yeah,
It
come
says
on, yeah,
public
come on.
forum, so-
Yes, for sure.
All right.
So when is it that you plan to have this, like, you're planning on passing this then to?
Well, your question goes to Madison.
Oh, yeah, So the timeline, you mean?
Yeah, like,
Right.
so it looks like you're looking at passing it,
Mm-hmm.
and so when are you looking at passing? Because we want to put in our comments.
Exactly.
Myself, I have some concerns, but.
Right, for sure.
And other things that I like to hear now, but.
Yeah.
When is your deadline? When do you plan to pass it?
Right, so right now we're in the public consultation period, so we're reaching out, seeing if anyone has comments, concerns, and that'll be till April 30th of this year. So you can provide your feedback online, email us, or through our online link. Then we're gonna compile all the comments and questions and put it into a document. After that, it will go to the, what's called the 4 agency committee for about 2 months. They'll look at it. And then if it passes that, it will go to the Canada-Ontario Agreement Leads, which would be about 3 months. So it's going through a rigorous process of probably about 8 months before we might, even into next year, where we could see if this will be redesignated or not.
So the delisting specifically deals with PCBs and mercury.
Yes.
So is it only, the data you're collecting is only through the fish that you caught that have it? What about things like, so some of these fish, the smallmouth bass, billy, amphibians like frogs and that sort of thing? Are you looking at the contaminants within their food supply as well, or it's just basically the fish because whatever their level is means that whatever they're eating has a low level as well?
So I guess there's a couple of dimensions to your question. So are you sort of talking about from humans eating other things like crayfish and frogs and their exposure to that, or are you talking about more of a food web biomagnification dynamic?
Well, this whole, exercise is about delisting the fish.
Yes.
Right? So, no, I'm talking about the PCB levels in the fish, but you're looking at each, I don't know, I'm just wondering, does it matter that, the amphibians are eating toads, frogs, whatever else they're eating, their food source, not just the sediment, right? I mean, I get it with the brown, whatever, the catfish, being the scat, whatever, eating on the bottom, they might get it from the sediment. But other fish like the bass that are eating specific frogs or something, are you looking at PCBs and mercury in those?
So we do have data on the entire food web. And so part of I did a bunch of modeling studies on food web bioaccumulation PCBs through the system. I didn't present that today because that would be another 25 minutes. But part of the validation of that model was to basically calibrate. So that model basically goes from water and sediment, and it predicts PCB exposures to everything from insects to small minnows to invertebrates to things like crayfish. Doesn't do frogs so much, but then based on the concentrations that are predicted in lower food web, it predicts biomagnification in upper food web. And that model proves to be pretty accurate. Like we can peg predicted concentrations in fish within a factor of 2 of their actual values. And it's an entire food web based model, so it covers all of the food web elements. A whole bunch of them validated with actual samples.
Go
Go ahead.
The catfish species there, right?
Yeah.
Are they like you're saying the bass are kind of, they're kind of localized, they're walleye, they're coming from all over, they're more of a traveler kind of thing.
Yeah.
Are the catfish more of a localized species as well?
Channel catfish are movers. They have a high trophic position and they're very fatty. And as a fatty fish, they tend to accumulate PCBs. So that's why they get more restricted in us.
My concern is I don't know, I don't like the idea of delisting it just because the river, it's a thoroughfare, right? So things are flying through here, coming from all over, Lake Superior, Lake Huron, all the different lakes. Find that, sure, looks like the bioaccumulation's low, but maybe because we're getting our samples are from Lake Huron or Lake Superior, as opposed to ones that are really isolated to the Detroit River.
Well, that's part and parcel why brown bullhead and smallmouth bass were chosen because they're known to stick around. And they're gonna be basically more resident fish, but we do know walleye tend to move around, but they're also the number one sought after and consumed fish. So basically, there was recognition that walleye were moving around. And, you know, in this case, you know, they're only getting about 20% of their burden, from the Canadian side of the Detroit River. Smallmouth bass is, at least about 50%. And the bullheads we think are highly philanthropic. They're very localized. They don't have very large origin.
Wouldn't people, as the person who's eating catfish, wouldn't people mostly eat channel catfish and would that be? Like, I understand from one of your other presentations that there weren't enough, like you weren't getting enough to meet the 100% of your samples. So when choosing the brown bullhead, right, that like as a comparator, right, that most people would be, I would think that the channel or channel catfish would be more prevalent.
Let's talk to the fish consumption survey expert.
Sorry, can you repeat the question for the?
So my question is, why the choice over the brown bullhead? I get that he's saying that they're more centralized, but I would think that more people would be eating the channel catfish, they grow larger. That's something I'm familiar with. Brown bullhead, I had in my aquarium.
Oh, right, yeah. So during our fishing survey, so here, if everyone has it, you can open up the page. When we interviewed different anglers, it shows what anglers consumed. So you can kind of see where the brown bullhead versus common carp lies. And the channel catfish and the brown bullhead are very similar in the sense that 48 people ate the channel catfish, whereas 43 ate the brown bullhead. So it just kind of shows that it's very similar in how much anglers eat that we did the survey on.
So, well, I guess questions lead to more questions, right?
Sure.
So I'm just wondering when your survey was done, how broad a survey, because
Right.
these numbers look really low because some people come for, say, white bass, you know, when the white bass are spawning and people are leaving with buckets full, right? So there's hundreds of people along the Detroit shore.
Right. So our survey was done in 2019 to 2022. And we had volunteers as well as members of our staff go out to various areas along the Detroit River area of concern. And we spoke to marinas, anglers at different times of day to get these results. So we had about 355 respondents to our survey. There was paper copies as well as online. So we'd really tried to get a really good sample size and had the survey open for a few years to compile this data.
Yeah, I've been involved in 6 other BUI #1 restrictions on fishing consumption in different areas of concern. This is one of the better angler surveys that are out there. Oftentimes they're trying to make decisions on 30 or 40 angler survey participants to get over 300. That's a pretty good number.
Because I'm still curious, I'm one that I'm concerned, because we also have microplastics now, right? So we have new concerns that we weren't looking at when it was identified as an area of concern, right, for consumption purposes, right? So I'm just wondering if that kind of specific data that you collected at that time is available, and if any of that new information is available or included in fish consumption ruling, right? So you're making a ruling, a determination whether you're gonna discount this as an area of concern. So that's
So I guess there's 2 aspects to this, and we're always asked, the big nasty is PFAS. Right? And PFAS compounds. So most of the areas of concern across the Great Lakes, as sort of said, these are sort of emerging chemicals of concern that came up after the RAP process had begun. And their sources are unique and different than what constituted the sources that contribute to the degradation of the apes. In the case of PFAS, it's a really interesting one because that is, and you could say the same for microplastics, although you need a more localized study. But for PFAS, it tends to be more of a regional contamination. And where you get now, advice generated due to PFAS compounds, they're not necessarily associated with the areas of concern, although they're present. So we do have some fish where some of those restrictions are due to PFAS, but they're not any more intensive than other areas that are not areas. PFAS seems to be one of these things that aren't concentrated in areas of concern. They're regional in their distribution. We see, I don't know, I can't tell you the story for microplastics.
Yeah,
I couldn't tell you the situation for microplastics, and microplastics are enriched in the Detroit River relative to other areas of the Great Lakes.
I think everything would be enriched, just for funneling that
Yeah.
coming into.
Now, if you're gonna compute, most microplastics that are in the fish are in the gut tract.
I'm sorry.
They're in the gut tract, they're in the GI tract. Most of the microplastics don't actually penetrate into the flesh of the fish. Get a subclass of nanoplastics that can, but for the most part, fish, microplastics go in and they go out. I've actually done research, I published papers on it. And so if you're not eating the GI contents, chances are you're mitigating your exposures. Most people are eating a fillet.
well, definitely want to learn more about it, so if there's, more information available. First of the read your papers, but that's part of wanting to make an informed decision or comments. Keep this. I mean, we know that so many other things, right? Like, we've been filling the Detroit River, right? We've been hardening the shoreline continuously. We've got microplastics increase with increased vehicle use and tire wear and that kind of stuff. So lots of degradation to our Detroit River and its watersheds. So,
You guys as researchers, you think you can confidently think that should be listed or be,
So in the case of the Detroit River, you've got two sides of the river that are managed independently. You got the US side, you got the Canadian side. It's gonna take more time for the US side for all those beneficial uses to pull out. On the Canadian side, the question really is, are there specific sources in our Canadian watershed that are independent of what's coming down the pipe from Lake St. Clair? But basically coming in from Canadian shoreline and point sources that are contributing to excess contamination on our side of the river. And I don't see that. I don't see that to a large extent. Now, that's for the legacy pollutants. We've got a lot of evidence that those legacy pollutants are declining the environment as a function of time. I think there's a lot of good news stories there. Emerging chemicals are concerned. There's always going to be a new chlorinated nasty that comes out, right? Or, halogenated nasty that comes out. I mean, this is a broader societal issue. But it basically, for the most part, the RAP processes, they're still trying to basically come back from 1987 when they designated this as an area of concern. What were the major problems and drivers of the contamination that we see today? And basically over that 40-year period, we've seen remarkable progress in that area. But we've got new contaminants, and new contaminants are happening all over the place, not just in the area.
but I guess the big concern is that it is another problem that needs to be addressed, whether it's more broad, but it's still is a vital freshwater resource that we have here. I would think that those would cause it to stay as an area of concern because of all the many pressures that are on this watershed in Detroit, Windsor's growth, all those things, right? Like, we're not lessening our impact, we're increasing our impact.
Yeah, I'm just going to disagree with you that we're increasing our impact. Globally, we are. I think as a local system, we're getting way better than where we were in the 1970s. There's no doubt about it. And the Great Lakes are improving compared to that 1950s and 1960s standards. Even with our algal blooms in Lake Erie today, they're not algal blooms like we had in the 1950s and 60s. Not by any stretch. I mean, things are better. We're not worried as much about the consumption of fish like we used to be in the past. We had past epidemiological studies. The Michigan Fish Eaters Cohort in the 1980s showed that, you know, mothers consuming a large proportion of Great Lakes fish, their babies had cognitive functional impairments associated with that. We have much less worry about that today, collectively across the Great Lakes. So I think things are getting better, unless we talk about climate change, which is a different story.
I'm talking about the pollution, like when we talk about the plastics, right? So the tires, when we were driving around, we're increasing, we're really paving at a phenomenal rate, right? Whether it's for new housing, you know, we're increasing our population, we're increasing our shopping mall, parking lots, all that kind of stuff. And
But we also have intervention technologies like, you know, the stormwater retention basin that was talking about. We've got vastly improved wastewater treatment processes today compared to what we had in the past. I think there's still a lot of improvements to go in our wastewater treatment standards to start collectively trying to treat for things like pharmaceuticals and personal care products to destroy them out of the sewage before they actually get into the waterways.
yeah, like these microplastics that, I mean, a friend of mine, she has a bottle of the scrubbing, you know, the body scrub microplastic stuff, right? That stuff's still on the shelves. I thought it was supposed to be removed, but they didn't catch the date when that was supposed to end. But those are the things still going down people's sinks and to a lot of ways and.
I have a question for the two of you, and maybe it's kind of like what you're talking about, Tricia. So with the RAP, there's specific criteria that's been set out that we have to look at. And we know that there's some limits to some of that criteria, but past the RAP, even if this is redesignated and some of the other issues are redesignated, I don't think that in our community, in our region, Detroit, where will be considered, oh, don't worry about it, we don't have to sewer the river anymore. I think there's gonna be some more focus on the river. It's just, this is the RAP plan that we're working through in this framework.
Yeah, I mean, there's a lot of aspects of the life after delisting, right? And what kind of monitoring programs are going to continue to go through. The official mechanism is once if the Detroit River becomes delisted, and that's not going to happen until you get two other impairments beyond fish consumption restrictions on the Canadian side. And it's also not going to happen until the US gets, I think it's got about 7 impairments on the US side right now. So the Detroit River as an area of concern can't be fully delisted until both sides of the river meet that. So that's still some time away. But the concept is once the area of concern is delisted, then it basically gets subsumed into the lake-wide management plan that is Lake Erie. So and then things like Ontario's Guide to Eating Ontario Fish, that monitoring is still going to happen. And they're already committed to keep that program in place. So.
Sorry, I missed which line you're referring to.
So basically that the Ontario's fish consumption advice,
Okay.
it's Guide to Eating Ontario Fish. They're still going to be coming into the Detroit River every 4 years, whether the Detroit River is an area of concern or not. So that Great Lakes fish contaminant database and monitoring is happening all the time. So it's not predicated on basically being an AOC. But by that same token, like, this is great that you're voicing these concerns and you're asking these questions. You know, really, you know, the whole Great Lakes Water Quality Agreement, it came about out of protests and out of basically voices from the public saying we do not want our environments. You know, I think Jacques Cousteau came the one time in the 1960s and he said Lake Erie, and he said he called it a dead lake, right? And Lake Erie is no longer a dead lake, but part and parcel because of all of the cleanup actions that happened through the Clear Water Quality Agreement. And it wouldn't have happened if it weren't for people like you. So basically holding the government's feet to the fire and saying, we want our environment. So yeah. It's tough on me, I'm in the hot seat trying to defend the position, but I also tell my class, you know, and I always give them the story from how important environmental advocacy is. And that, you know, I think you sound like a really engaged person, so, if, you know, one of the things I have my students do, I'm not trying to tell you to be like my students, but, so they got like the Ontario Environmental Registry, I don't know if you're familiar with that website, but it basically talks about all the ongoing projects. And I usually have my students, in my courses, they're scanning for all of the Windsor Essex projects.
Thank you.
That
Good
are,
for you.
Thank you.
Yes.
Because we do.
excellent,
Comment.
excellent. I'm glad you do. Because you're probably also aware how many of those projects you look at and it's like it passes, you know, commentary zone and no commentaries.
Yeah,
So it's really valuable.
thank you.
Most of the fishermen I know, we're basically looking for perch pickerel. And that's eating fish. And looking at the advisories here, one might reach the conclusion that the upper reach of the river is more polluted than the lower reach. Can you explain that, or is that not true?
Yeah, I have my debates with the Ontario program about that. I actually think, you know, when I do the statistical analyses, I treat fish from the upper and lower river together. And I actually try, remember I talked about that, the chemical fingerprinting process to show where fish move around. And I can't find a distinct difference between fish from the upper part and the lower part of the Detroit River. Although there is a little bit more connectivity of obviously Lake St. Clair fish moving into the upper part of the Detroit River. And there's a little bit more of a mercury issue in Lake St. Clair historically. So that might be some of the reasons for the high price. But I don't think fish from the lower river and the upper river are different populations.
Okay.
And the way those advisories work, right? So they're evidence-based, but they're based on the records that they have. So they catch a bunch of fish from the upper river, and they catch a bunch of fish in the lower river. They look at contaminant concentrations. They figure out how contaminant changes as a function of size, and they use that statistical relationship to come up with the advice. So you get a slight difference in the nature of, you got a few larger fish on one side, two smaller fish on another side. That can change the nature of that interpretation.
So those studies with sample sizes are available. Right.
So like actual fish contamination?
Yeah, like the sample study. So because when I saw the 300 some, you know, surveys, that doesn't sound like very much to me, when I see hundreds of people out for one species of fish.
So you're talking about the angler survey?
Well, just not the angler survey, I'm just using that as an example to understand like, what are the survey numbers of fish that you're using for your determination, for analysis, and then where do I find that specific information?
So, good question. And both the Ontario government and the Canadian government are committed to basically transparency in data sets. But some of those data sets are very hard to find. You know, I can share with you the clear data that I have.
Okay, that would be.
I own,
Okay.
I've got the MECE data that I'm in permission to share. Now, I do believe that both governments are racing to fulfill their data transparency requirements by putting out data sets. So I noticed now on the Ontario Guide to Eating Fish, they have a fish contaminant database. But the contaminant database basically tells you what the advisory levels are. It doesn't tell you the actual concentrations of the individual contaminants. I suspect in the future, they'll start to put that up. Just like Ontario also puts up all the drinking water testing data online. So I think, it's about 5 or 6 years ago. It was before the internet. Jeez, that's been 5 or 6 years ago. Okay, maybe 10 years ago. Remember we had the Canada lead crisis? Or it was the so-called, we had the Flint water crisis for lead. And then what sort of happened is about 5 years, about 10 years after that, Health Canada dropped its recommended lead, water quality guideline, drinking water quality guideline for lead in water. It used to be at 10 micrograms per liter, and they dropped it to 5. There was a study at Carleton University where they went out and they collected a whole bunch of tap water and ran them for lead analysis. Now, they were a little bit cagey. They said it's like 40% of our drinking water is above the allowable water limits, which wasn't true because Ontario had not yet adopted the Canadian standard. And so, and it was, I've worked in this realm of toxicology of trying to basically find the statistical signal between no effect and a threshold effect. Okay, and you're walking the line of a lot of statistical noise. And some approaches are a little bit more conservative, some approaches, and they adopted a little bit more conservative approach. And ended up dropping the water guideline. But one of the great things that I found out is I was getting a lot of questions and calls about lead in our schools. And all of Ontario's drinking water, basically monitoring, requirements for drinking water monitoring across the school, that's all published in our lead concentration. So I was able to look at how frequent lead exceeded that 5 microgram per liter, the new standard, and 10 microgram per liter. And there was occasional, jumps in between that noise because all the infrastructure was spec'd out to the 10. But it was actually pretty good around here. So that was a huge segue, and I apologize for that. It's on segues. But what I am saying is the governments are making better and better progress in making their data sets available. The USCPA, they have their STARS website. They make their contaminant monitoring data and provision available. So, and yeah, I'll give you my business card. You can contact me. I'd be happy to share what I have.
Okay, thank you, I appreciate that.
Yeah.
And yet there's also the sediment remediation group on the US side. And I can also provide the link for that as well. So you can see what type of work they're doing and their progress for that as well. So yeah, but we appreciate all the feedback and comments tonight. It's really going to help us as we go through this period of time. We just really appreciate all the comments. Anything online? All right. Well, thank you, everyone.
All right. Make me feel alive.
Thank you, everyone, for coming. Appreciate it. Have a great rest of your day.
You're asking about 2 hours. Yeah.